is Kathy Fueling. I'm a former teacher from Pima Community College East Campus. I taught chemistry for the Pima Community College system for 40 plus years and am now enjoying working with our women's chemistry group, especially in activities like Silly Putty.
Hello, my name is Silver Kulshins, and I would like to welcome you on behalf of the Women's Chemistry Group to our 12th annual Silly Putty presentation. And so I would like to say that it should be an adventure of making Silly Putty, which is also called slime. And so hopefully you'll get to have some fun, and it's combined with a little bit of learning as well. So you will be making individual batches of Silly Putty as described by your teacher. And it is, we ask you to think about the reactions that are taking place, the changes that are taking place. So we'll probably see some physical changes and some chemical changes. And overall, so we have two ingredients that we are going to combine. It is some Elmer's glue, and then it's borax. And we're making a new substance with new properties. Chemically speaking, polyvinyl acetate, the active ingredient in Elmer's glue, plus sodium borate and borax, yield a cross-linked big mega molecule we call Silly Putty. And as we perform this reaction, we'll think about the nature of each step and decide whether it's a physical or a chemical process, thinking as a chemist would. Let's get our reaction started.
Okay, to begin, we're going to look at the items that we need to do our experiment. In a kit sent home with you, you should have your diluted sample of Elmer's glue tinted to your favorite color, we hope. You should have a baggie with a teaspoon of borax. And then from your own home supply, you will need a small container of water, a measuring spoon that will measure 1 tablespoon, a support cup or mug, something that will hold your baggie while you make additions, and finally at the end, a plate to work your Silly Putty on. Let's go. Now have these assembled before you and follow through the steps as I do them. Open your baggie and carefully place it into your mug, opening it wide. Our first addition will be the tablespoon of water. Measure the water to the level and transfer it to the cup that has the baggie in it. Then remove the baggie and ziplock it shut and start the dissolving process. This will take a little bit of time, sometimes a minute or two is good. You want to get the crystals of the borax dissolved as much as possible. The solution will remain cloudy, though, I'm sure. It never gets totally clear. And so we are completing the dissolving of the crystals.
You are getting your borax ready for reaction by loosening the individual particles, sodium and borate ions, in a water solution. While your crystals are dissolving, think about what is happening. The particles are being freed into a water solution so they are able to react individually with the glue particles. In the solid state, all the particles are tightly held to each other and would be unreactive. Substances dissolved in water are free to roam while keeping their individual identities. If the water is evaporated away, the particles return to their original crystalline formation and again are locked in place. This is a physical change or process which is described as one where appearances change, but identities are not lost. Different look, same stuff.
Well, now we're going to continue. We have dissolved our borax to a sufficient amount. Now return the baggie to your support cup. Open it wide open. Now comes the fun. We will be opening our medicine bottle of diluted Elmer's glue and then add the glue to the borate solution. Make sure you let all the drips, the final drips, go into the baggie. And then remove the baggie carefully, expelling as much air as you can from the top, and zip it shut. Now more massaging, this time more vigorously, maybe with both thumbs, getting the substance. Can you see what's happening? A major change taking place? And we will find that the borate particles are getting close to the glue strands and forming our product. This means that there are bonds breaking and bonds forming. Whenever you do chemistry such as bonds breaking and forming, we will find that energy is involved. Do you feel the chill associated with this?
While your reaction is taking place, let's talk about chemical processes. In this situation, as substances react with each other when mixed, their original composition is changed, and each reactant's identity is lost as a brand new substance or substances is formed. Let's meet our two reactants. First, the glue's active ingredient is polyvinyl acetate and consists of long chains of carbon atoms, 100 to 1,000 or more per string. Every other carbon atom in the chain having a reactive site to which the borate balls can attach. Second, the tiny borate ball, on the other hand, has two reactive sites which can attach themselves to different strands of the glue's polymer. This results in it tying together strings into large interconnected networks which chemists call a cross-linked polymer, and we call silly putty. All these steps prior to this one were physical processes: the dilution of the glue by your teacher, the addition of the dye, the solution of borax in water. In every case, the original substances could be retrieved if desired, and no alteration of construction has occurred. But your final step was again a chemical process, a chemical reaction in which a whole new substance was formed, which you are holding in your hands, silly putty. I hope you enjoyed this session, and we all regret not being with you in person. Enjoy your silly putty.
Okay, to finish our product formation, we will take it out and work it even further. Open the baggie and dump the entire product onto your working surface. It might be a little plastic plate or a plastic sheet that you have, a placemat, something like that. Now you'll find that this is kind of sticky and gummy, but what we find is that if you knead it and work it, much like if you were making bread dough and need to knead and work it, it loses that stickiness and has a consistency that really works nicely. In fact, once you get it to that point where it's not sticking, you can even use your silly putty to clean the remaining parts off of your bag so that you have a nice clean bag to store your silly putty in. So continue doing that and kneading it and working with it, and in the end you have a nice sample of silly putty. We certainly enjoyed working with you today. Thank you.